my academic background is in zoology, more specifically ecology, even more specifically insect population dynamics. One of the questions posed to us when I was at university is, why are the populations in tropical forests relatively stable when tropical forests are immense in scale and enormously complex? If we contrast, say, with the populations of Arctic hares and Arctic foxes, those oscillate rather wildly. So again, the question was, does complexity lead to stability, or does stability permit complexity? And I think we can think about data ecosystems in those terms. Admittedly, data ecosystems aren't like, a real ecosystem, but neither are they engineering products. They're not machines. They may be actually closer to ecosystems than we think. And if we think about the typical data ecosystems we see today in many companies, many organizations, they are complex. They are large in scale. So are they going to be stable because of this complexity or not? I think, unlike the tropical forest, complexity will not lead to stability. Now, what do we mean by complexity? Complexity is generally not the number of dissimilar things, not, say, pure biodiversity, but the relationship between them. So in data ecosystems, we can see relationships of maybe three kinds. One would be logical relationships. I'm thinking of foreign keys between tables. We also have data flows, that is true data lineage, where data is moving from one place to another. And then we also have the temporal synchronization, or lack thereof, of the processes that act upon that data. So all of these are working together. And I think that what we've seen over the years is an accumulation of complexity, but stability, meaning that how fragile are these data ecosystems, has probably increased, because the number of relationships, not just data lineage, not just logical relationships like foreign keys or simply process dependencies, but all of them together, all of them mixed in, it's extremely difficult to understand them. And if we perturb one of these relationships, we can damage many others. And we frequently hear about upstream changes causing downstream problems. And this is important because it may be the case that for newer layers in the architecture, where there are fewer relationships, they appear to be more stable, but over time they're going to get more and more complex as they kind of get wired into the rest of the data ecosystem, and they will become less resilient to changes. They'll be impacted more by, again, some change upstream that nobody understands is really related to them. So I think that complexity does lead to loss of stability, and that loss of stability is reflected in a tendency not to interfere with things that already exist, where it's known there's a lot of interrelationships. We talk about, how do we keep the airplane flying when we're changing the wings? Those kinds of metaphors are very frequently heard about in data architectures. In a worst case scenario, this is going to mean that our architectures are going to become more sclerotic over time, and our enterprises will be less adaptable to, say, changes in market conditions, competitive conditions, even technologies, and it's a real issue. So I think that just accumulating layers and complexity in our architectures, perhaps by having like just a sea of independent projects developing data pipelines, will ultimately add to the complexity and reduce the stability of our data ecosystems. And in this sense, they're not really like the tropical forest.